the Astronomy 324 Final Clock Project. My name's Dina.
Alex.
Chris.
And Kevin.
Sean.
And I'm Jason, and I'm going to talk about the display portion of the clock so we can get it running and you guys don't have to watch it for 3 minutes. So, our display is relatively simple. We have two aspects. We have a 10-second display and a every 10 seconds display. This being the tick-tock of our clock. And as it goes around, you can see that it'll hit the equals button of the calculator. What this does is it adds 10 to our counter, so we know how long has passed since the clock has started running. You'll notice we started at -10. This allows us to have it on the first tick count 0. As it goes around, you can see that we've numbered each of these equally spaced tick marks, so we know how much has passed since the last 10 seconds. So, for example, right now, it would be at 6 seconds past the last count.
The reason we've set up everything to be in 10-second increments is because our motor has a 6 RPM, where it means it rotates 6 times in 1 minute. That means every time that bronze camshaft goes around, it's been 10 seconds. So we've turned on the power, you can see the camshaft rotating, and we're going to go ahead and start our clock for you guys.
We'll start these timers the second it gets to 0. So as you guys see, we have 2 timers running to help us compare the time that our clock face gives us versus our actual display. So as you guys will see, it goes up 10, which means we're at 10 seconds. Then if we look at this display, there's 14, 15, 16, 17, 18, 19, goes up 20, the calculator says 20, and as you guys can see, the timers are about on. So right now, I'm going to go ahead and explain the escapement of our clock, and the escapement is what allows the energy to be released. If you guys remember the pendulum clocks, it had that escape wheel that the mass was tied around, so it actually spun. Well, our escapement here is ultimately this whole circuit. It all helps facilitate how the energy gets pushed out, but the main part of the escapement is our motor. As you guys can see, the motor is actually rotating here. That's a little bronze camshaft that we casted at the craft center on campus. And as you guys can see, it's rotating around much like the escape wheel of the pendulum clock.
I'm going to explain the regulator for our clock. In the case of a pendulum, the regulator was the length of the pendulum, which defined the period of the pendulum. Since we're dealing with electronics, our regulator is this variable resistor, which we control using the knob to the right of the clock face. Turning this resistor left or right increases or decreases the amount of current flowing through the motor, which then determines the rate of rotation of the motor, or the RPM. This is analogous to lengthening or shortening the length of the pendulum, which changes the period in that case. And since we are using electronics, our power supply is clearly going to be electricity. We're using 120 volts out from the ground, coming up here to a 9-volt DC output transformer. That gets put into our circuit board here, and we can further regulate it with the variable resistor, getting whatever voltage out we desire.
One more thing you guys may notice is we have a little multimeter hooked up over here to actually watch the voltage that's running through our circuit to make sure everything is running the correct way. So you guys see too, we haven't stopped it, we've kept it running this whole time, and we're going to just wait and see how close we can actually get to 3 minutes with our clock that we have built.
We are basically waiting for the calculator to show 180, because 180 seconds is 3 minutes. So we're getting close, and let's see how close we can get to the actual time.
You guys saw that? It turned to 180 almost exactly at 3 minutes.
Beautiful.
Beautiful. And we're going to go through a quick little summary of everything that we had here. First of all, our time indicator is going to be that little camshaft rotating around. Each little tick is a 1 second increase from the tick before it. And then our calculator shows every 10 seconds. So this is a 10-second counter. This is a single second counter. Then our regulator is this variable resistor. As you guys see, if we rotate it down, the rate slows drastically. And as we rotate it up, it's going to increase a lot more. You guys can also hear how much the motor is actually changing. Bring it down a lot. So you guys can see how it slows down drastically. We even got it to stop. So that is our regulator. Then the escapement, again, is the actual motor itself and the circuitry. And then our power source is going to be that little DC converter transformer right there. As you guys see, if we unplug the power source, the clock actually stops. So we need the power for it.
We've actually slowed down the video and taken snapshots of the second the calculator turns to 180 seconds. This is right before it turns. This is a picture of the actual moment that the calculator hits 180. If you guys can see, the 8's a little bit blurry because we were lucky enough to actually catch it in the middle of displaying an 8. As you guys see, one of the timers says 3 minutes and 1/100th of a second. The other says 3 minutes exactly. Now, this is a picture of right after that. You guys can see the 8 actually cleared up a little bit, and both timers say 3 minutes and 1/100th of a second. So we have actually timed down to 1/100th of a second. Just so you guys know that we weren't messing with you, here's a couple looped segments where the movie's been slowed down so you can actually see the change happen with the timers.